I'm in 5th grade, and this is my Bouncy egg experiment. So, my purpose is I am doing this experiment to understand how much more fragile the egg is once it is bouncy. My problem is, if conducted correctly, why does the egg become bouncy and transparent? Hypothesis. I predict that the eggs will become completely transparent at the 56-hour mark of the experiment. I believe it will also become bouncy at the 56-hour check. Once the egg becomes bouncy, I believe the egg will still be quite fragile and most likely will break at 20 centimeters. Materials: eggs, vinegar, 4 mason jars, food coloring, latex gloves, plastic fruit dehydration mat, and glass bowl and a kitchen sink. First, you need to gather all the tools necessary to conduct this experiment. Next, you will fill several mason jars with vinegar. Then, carefully place a raw egg in each container. Afterwards, you will need to wait 48 to 72 hours for the egg to become completely transparent and bouncy. During this wait period, you will need to check on the egg several times. Finally, when the water has a film on it, the eggs will be ready to take out. Independent variable: the amount of the time the eggs get in the vinegar. Control variable: the control variable are that the eggs all from the same carton and each jar has the same amount of vinegar. Each test sample is kept at the same room temperature and in the same location. That's important. Dependent variable: how bouncy and transparent they will become. So these are my materials. These are when I put the food coloring in the vinegar, and this is like immediately they started having bubbles around, like tiny little bubbles. This one was like as soon as we started, and this is when I was putting it. Where was it? Experiment checklist: 12/9/24, 7:10 p.m. Began experiment. Instantly became surrounded by bubbles. 12:10/24, 7:20 a.m. First check. The egg swelled a little and had already started to absorb the food coloring. 7:20 p.m. Second check, 24-hour mark. The eggs were extremely large and had completely absorbed the food coloring. 11:24, right before day. Third check, 7:20 a.m. The eggs did not appear to change. 7:20 p.m. Fourth check, 48-hour mark. The vinegar was scummy, and the eggs were completely transparent and bouncy. The experiment only took a few minutes to complete. Results. At the beginning of this experiment, I noticed that the eggs were completely surrounded by tiny bubbles. They also started to absorb the food coloring. This is because eggshells are extremely porous. At the 12-hour mark, the eggs seemed to be enlarging. At the 24-hour mark, the eggs were large and absorbed the food coloring. For this experiment, I just decided to use 4 eggs: 1 blue, 1 yellow, 1 red, and 1 green. The yellow egg seemed to be the only egg that did not completely absorb the food coloring. The yellow egg also progressed slower than the others, such as the red egg being the fastest to react. At the 36-hour mark, the eggs did not appear to change in any way. At the 48-hour mark, I decided to check the egg because at the top of the vinegar was scummy. As I was trying to remove the red egg, it busted. I don't know why that happened, probably because of the pigmentation in it, and that's why it went faster than all the others. Where was I? Then I started to pour out the vinegar and eggs into a glass bowl very carefully. This method of removal is highly effective. Only having 3 eggs left to conduct my experiment, I chose to use the yellow egg first. I placed a plastic fruit dehydration mat in the basin of my sink to act as a shield from the metal sink. I started my experiment by dropping the yellow egg at different heights. The first being about 2 about like 7-9 inches like this, guys. 0.79, whatever. And then 6 centimeters, about 2.39 inches like this. And then 10 centimeters, like this. But it was like not big. So, and then finally 15 centimeters, about 5.91 inches, like this. So they were not very strong. I thought they would be really strong. I repeated the same process with the blue egg and yielded the same results. When I moved on to the final green egg, I noticed I bounced the egg at a different spot and realized that the bounce was much springier. I decided to keep the stored spot for every bounce. I was able to bounce it all the way from 48 centimeters, like this, guys, about 1.57 feet, without breaking the egg. Then I thought to try bouncing it at 48 centimeters, about like the same height, at the original spot in the center of that mass. At that point, the egg busted. This concluded my experiment. So this is me dropping them. Cause this one seemed actually the largest in my hand. Probably because it was going like this. See if you can see it better. And it was like not very strong. This one is stronger. And this one was like kind of the strongest. I'm thinking like the pigmentation again. Conclusion. I now have better understanding of how the egg becomes bouncy and transparent. Due to the eggshell being porous, vinegar can enter the tiny holes that break down the shell's enamel. The bouncy egg is extremely fragile to pressure from your touch, but is not so delicate when bounced at a certain distance. Compared to the raw eggshell, which is much more resilient to your touch, but will completely break if you try to bounce it, which you can't. I discovered that the farther the mat was from the bottom of the sink, the less effect the fall had on the egg. This is because the black mat acts like a trampoline to the egg, softening the landing. Since the egg is fragile, when the egg was dropped on the center of the mat where it was closest to the middle of the sink, it would break at a measly 15 centimeters, about 5.91 inches.